Hey y'all, we're in chapter 16, and so we are talking about probability models. There are two models that we will examine, geometric and binomial. So for the geometric model, we have P, which is the probability of success. And then we have Q, the probability of failures. And so the way that P and Q are related is that Q is equal to 1 minus P. All right, so the way that we calculate our mean, which remember is also expected value, is 1 divided by P. Standard deviation is calculated by taking the square root of P divided by Q squared. And in general, whenever we're doing the probability model, the probability of X, our random variable equal to some number, is Q raised to the power of X minus 1 times P. All right. Okay, so then there are three things we want to check for to determine if it's a Bernoulli trial. In order for us to move forward with, calculating our probabilities. The first is that there are only two possible outcomes. And so those outcomes are either a success or a failure. That's the only two options that we have. Then we want to make sure that the probability of success is the same for every trial. And finally, we want to make sure that the trials are independent. Okay, so that's our three criteria that we want to check. Next, we're going to discuss the independence versus 10% condition. So in the event that our trials are not independent, we want to make sure that we have randomly sampled fewer than 10% of the population before we can proceed. All right, so now we're going to determine if these trials are Bernoulli or not. So it'd be a good opportunity for you to actually pause the video and work the problems out. Don't speed ahead, read each scenario, make a decision. You didn't pause it. Okay, so the first one would be yes, because you either roll a 6 or you don't. Now with the second scenario, it's no, because there aren't only two possible outcomes. The third one would be a yes, because we're talking about either a Democrat or a Republican. And then the fourth one is actually no, because we surveyed more than 10% of the population. Okay, so if you have any questions, make sure you write them down in your notes and we will continue. All right, go ahead and read example number 2 and we'll prepare to discuss. So we wanted to choose a variable. We're going to let X represent the number of candies selected until you get a speckled candy. And we went ahead and found our probability for success and probability for failure. Recall from the top the formula to calculate our probabilities. And so that's how we end up with 0.7 to the third times 0.3, and we get 0.1029. And so the probability that the first speckled one we see is the fourth candy is approximately 10.29%. Okay, and so we continue to follow that model for each of our problems. Okay, and so the next one where X was equal to 10, we have 7.7 raised to the 9th power times 0.3. Okay, and so that gives us 0.0121. All right. All right, so I would say pause the video and try the next problems on your own and then press play. All right, so remember at the beginning, we found that the expected value for a geometric probability model would be 1 over whatever its p-value was. So when we do 1 over 0.3, we get approximately 3.3 repeating. And so that would be what we would expect for the number of Skittles. All right, so example number 3 you'll do on your own and we'll check in class. What I want to show you now are the calculator steps you'll need for the 84 in order to do a geometric model. Okay, so here are the formulas that we need for the binomial model. Notice that we're still using P and Q for probability of success and probability of failure. The formulas for expected value and standard deviation are different, as well as how we calculate the probabilities when dealing with a binomial model. Now, the notation that may be foreign to you is the N over K, which is what we call N choose K, our combination notation, using the factorial. So we will discuss that in class a little further. So if you would copy down this information and take note that for the binomial model, the success and failure condition is what we examine. And so we want to make sure that our expected number of successes and our expected numbers of failures are both greater than or equal to 10. So if you would go ahead and copy these formulas, and then we will continue the rest in class. Thanks for watching.